Hello, welcome to a crash course in circuit theory. In this video, I will continue the discussion regarding signal conditioning subsystem for the microcontroller. I will first talk about the limitations for current, and then I will talk about the options that are available for conditioning the signal to be ready for the microcontroller. We mentioned before that if a voltage is higher than another voltage, current will flow from that point to another point. Here's a situation where we have a voltage at the input circuit which is actually lower than the internal voltage that's inside the microcontroller, which means current will actually flow out of the microcontroller into the input circuit. So the microcontroller in this position is acting as a source of current. If current is flowing through the microcontroller, then of course it will begin to become hot. If too much current flows out of the microcontroller, then the microcontroller will become damaged. So what determines the limit for this current? Well, the value of Rs in this situation, it does. Which means this right here cannot be too small, because if it is too small, it will bring out too much current and the microcontroller will become damaged. And you look at the data sheet to find out what are the limitations. We call it the output source current for the pin. Now we're going to talk about the various signals or the various conditioning circuits that are available. We mentioned before that the microcontroller can receive digital inputs, can only receive digital inputs, but the actual signal from the sensing device can be digital or analog. However, sometimes you may not be able to connect these digital components directly to the microcontroller. You have to do some kind of conditioning. Since the signal is already digital, that saves us a few steps. If the signal is too large, you might decide to use a voltage divider. If the signal is too small, you may decide to use an amplifier and apply any one of these four functions as well as other more advanced functions. If the digital signal is a little bit dirty or has a lot of noise, you might want to add a Schmitt trigger to help clean up the digital signal itself. Remember, the microcontroller can accept many types of digital signals. Of course, it can accept the normal on-off, but the microcontroller can also read advanced signals. It can read the width of a pulse. These are normally used by ultrasonic sensors. It can actually read the frequency of a periodic signal. You can write a program to measure the frequency. And you also can read frames of data. Typically, microcontrollers read 8 bits in one frame. So you can imagine that this here is an 8-bit set of data. 01001010. So it can communicate with complex components. All of these options are available for the microcontroller as a digital input. You can also take these individual bits and send it across 8 different wires, which means that into the microcontroller you can actually send it as a group, which means you can connect 8 wires to the microcontroller, and the microcontroller can be programmed to read all 8 of these voltages at once, and it can once again save it as an 8-bit code or an 8-bit number. These options are available for digital inputs. Now for analog inputs. Well, the first thing that you have to do is consider the fact that it has to be changed to digital at some point in this process. But the analog voltage has the same issues as digital voltage. It could be very large, so you may have to apply a voltage divider to reduce it. It could be very noisy, so you might have to use a filter to clean it up. Or it can be too small, which means that you may have to amplify and apply some of these additional functions to get it to the right level. If you're only interested in determining whether an analog voltage is above or below, you might want to apply an analog comparator and create a set point where when the voltage goes above a certain level, it'll output a 1, and when it goes below a certain level, it'll output a 0. You have a threshold, and if it's below, it'll be 0, and if the voltage goes above, it'll change to 1. So that is your analog to digital conversion. If you're interested in knowing all the values along this curve, then you'll need a full analog to digital converter. Most microcontrollers today has analog to digital converters built inside. These come in various sizes. It could be scaled to 4 bits, 8 bits, 12 bits, and even 16 bits. It depends on the range or how many points along this analog curve that you need to read. 4 bits allows you 16 different points along this curve. 8 bits allows you 256 points. 12 bits allows you 4,096. And this is very common for most analog applications. But if you really need to have very, very close representation of the analog data, you can actually go to 16 bits, which will give you 65,536 different points along this analog curve. There are circuits out there that allows you to convert from analog to digital using frequency. And of course, we said there are circuits that also take an analog signal and change it into a pulse that can be read by the microcontroller. Examples of this would be the ultrasonic sensor. In the next video, I want to summarize the signal conditioning subsystem to be sure you understand your major options. And I have to conclude with the fact that you will be able to solve these problems by referring to your instrumentation and controls class 1 and 2. Thank you.